Thank you everybody for coming to the very last session of the evening. I'm the only one that's standing between you and non-alcoholic drinks, I'm sure. My name is Erwin Valk. I'm a developer from the Netherlands, and I currently work for, as you might have guessed, for Duende. However, this talk will not show that much from Duende software, so doing my best. We're talking about access tokens being stolen. That is interesting. I do a lot of martial arts, if you don't know that. And one of the things I've learned with martial arts is that if you want to learn how to defend yourself, you have to know how to attack, right? Because you need to train with somebody else. So we're going to attack a little bit, get a little bit of fun, and then see how we can defend ourselves against that, okay? So this is the agenda. First, tokens in the browser. You know, everybody's doing it. Why are you making such a big fuss about that? After that, I'm going to show a perfectly well written React application. Nothing to see here, it's all good. Then we'll see how the BFF pattern can help you with that. And it's of course not the best friends forever pattern, although it might become your best friend. But anyway, I'm going to apply the Duende BFF security framework to solve this problem. However, you can also just create your own BFF. It's not that particularly hard. So let's look at that as well. That's going to be the agenda for today. All right, access token in the browsers. What's the problem? Why? Because everybody's doing this. Well, quick recap, access tokens. What are they for? Well, an access token contains claims about who you are and what you can do in a system, right? I'm Erwin, and I'm admin to every system that you can think of, right? Something like that. Now, I can make these claims, but that's, of course, it's very important who makes these claims and how do you trust these claims. So typically, access tokens come from a trusted party, an identity provider, or a token service, and they're signed so that nobody can tamper with them as well. That's important because otherwise I would just make myself admin in every system and it would just work. So we're not doing that. All right. And they are used to authenticate requests. We've seen that earlier in earlier talks as well, but you typically send them along with a request, and then, based on the information in that token, doors either open or not. Now, because of that, they're kind of like keys, right? They open or do not open certain valuable resources, things that you want to keep safe. And of course, if somebody steals them, you have a problem. Now, the other thing about what I put in the title is browsers, right? I mean, access tokens in the browser. Well, browsers are interesting pieces of technology. They are designed to execute strange code from all kinds of parties, in a reasonably safe manner, right? They're when you go on a website, typically, it downloads code from all over the place. And, on a news website, for example, all these ads that are popping up, they're all, code that comes from someplace. However, your Gmail, which might be on the same computer, you access that on the same computer, is not compromised by that. Why? Well, because, of course, browsers give you a secured sandbox. Within that sandbox, everything is safe, but things cannot easily go in to that sandbox. But sites are very important in this particular aspect, right? They protect from cross-site access, not necessarily what happens inside of that site. Because within that boundary, there is no security. If you go to any website and that website shows an ad, and that ad is compromised, it can do anything that you can do on that website. Now, for news websites or whatever, that's usually not that much of a problem, but this is probably a good reason why in banking apps they don't show ads, right? Exactly for this particular reason, I guess. Now, browsers are constantly under attack. They're an interesting attack vector, right? Because as soon as you have malicious code that leaks into a site, like I said, that malicious code can do whatever you can do as well. So if you can transfer money from one account to another account, then the malicious code that's running in that same site can do the same thing. If you can send emails to your best friends or partners or your business, malicious code can do that as well if they get into that one particular site. So of course we want to avoid that. But if there's malicious code that's in your site, and your site has access tokens in them, your browser has access tokens in them, they can take those access tokens and do things outside of the context of your site, but still under your credentials. And we're going to see a little bit about what that looks like, but that's what attackers will try to do always. Now, injection attacks, like where somebody injects code into your system, are still in the OWASP top 3. We would like to think nowadays, this has been in the OWASP top 3 for a long, long time, that we know what to do against them, but still, it happens all the time. So it's not that safe. But even if your code is safe, supply chain attacks, very relevant now, because we've all heard the NPM things the other week, right? Where somebody managed to steal roughly $100 in crypto from the world. Yeah, the actual amount of damage that they did was very little, but what they could have done if they've only hid their code and were stealing access tokens all over the place, they could have probably made millions, but they didn't. They tried to steal Bitcoin. Anyway, silly. But even if it's not an injection attack or a supply chain attack, there are other types of attacks that, like Spectre, that are attacking your CPU. So it's just, browsers are not a safe place. I guess that's one thing that I'm trying to impress on you. So now, if somebody steals your access token, what can happen? Well, there's various ways that people can steal access tokens. A one-time token theft is kind of like you just forgot to leave your window open, just tiny little time. And somebody got in, snatched something, and that's it. Now, it's annoying, right? If something that happens, if your token gets stolen, it's annoying. But as soon as you close the window, problem's gone, right? So this is not as bad, right? It's still bad, but it's not as bad as when you have a roommate or somebody living in your house that is constantly leaving the windows open. That would be worse, right? Now, this is what we call persistent token theft. Imagine a website that is constantly leaking access tokens. And we'll see some ways how that can happen. Well, if an attacker is constantly getting new access tokens, he can constantly keep trying to do more and more with these access tokens. And the worst one, of course, is if your refresh tokens get stolen. Now, refresh tokens allow you to constantly get new access tokens. Now, that's almost like you have a roommate who sits on your couch, steals all your stuff constantly, right? And you can't do anything about it, right? Because they're in your house, they're everywhere. They can do whatever you want. Now, the thing is, your credentials might not be enough to completely compromise the system, but attackers will use that. Once they can get into a particular system, they start probing for other vulnerabilities as well. So typically, as soon as they've got access tokens, they can, see if there are more and other ways how they can get by things. So very important, don't let your access tokens get stolen. The way to do that is actually to make sure that the browser doesn't have these access tokens anymore. That's just the easiest way to do that. Now, this is not a new thing. In March 2021, already based on certain specifications, Duende already created a version of the BFF that helps to prevent this. Other companies as well. I mean, I've been building BFFs for a long time as well. And, still now in 2025, a lot of systems don't use BFF type systems. Now, what did happen in 2025 is that the IETF, which is, who knows what the IETF is here? There's one. Okay, you do know what OpenID Connect is, right? Yes. Well, they're the group who actually created these specifications. There are all kinds of specifications that they're creating to make communication on the internet safe. They're the group who are doing that. And they came out with an official recommendation. It's actually a really good read. I recommend everybody to read this. Normally specs are a little bit dry to read, but this one's actually a really good read because they go in and they say, well, what can happen if your token gets stolen? What are ways how your tokens get stolen? And if they have them, what can you do with them? So it's actually quite a good read. I recommend people to go in here as well and read them. But the recommendation is not just, from us, because, we from, what's that thing? WC1 are selling WC1, right? No, but it's, it's an official recommendation from the standards body to stop doing this. Now, this is an example that I like to give. This is fairly recent, like March 2025. There was a flaw in the OneDrive file picker. Now, of course, OneDrive, a lot of people might use this to store files, maybe also personal files. And if you were to upload a file to ChatGPT, first of all, it gave you full access to your entire OneDrive. That's already bad, right? However, the access token that they had was stored in plain text in the browser so that ChatGPT could just take that access token and keep using it for however long. I mean, it's not just this. I mean, any app that was integrated with OneDrive could read your entire OneDrive. And if that access token got stolen because they have a supply chain attack or something, they could do whatever they want, including those refresh tokens, by the way, so that now somebody is sitting on your couch and is constantly just, how do you say, stealing your stuff. All right. So let's be a little bit evil, and let's see for a small React app that I built how we can break that. Now the React app that I built, let me show it, is I do need to apologize for it a little bit. I'm not a front-end engineer, so if anybody has better front-end skills than me, then you'll probably laugh at me, but that's fine. Here we go. I built it using Aspire, of course. There's three parts of this system. There's a front end. Let me maybe zoom in a little bit. There's a front end, just built with, like I said, React. There's a back end that exposes a web service. And there's also a profanity checker. So what are we doing here? Well, this particular app allows you to capture reviews. Now, before you can capture reviews, I do want to know who wrote them, because if anybody leaves a bad review, I'm coming after you, right? So you do have to log in. I'll log in. Bob. Perfectly safe. And here we go. You can log in now and you can leave a review. For example, best talk ever, right? And website, mine. There's no checks there. Okay, not so good. Anyway, doesn't matter. You can leave a review and hopefully, yeah, there it is. Now, just like most sites, there's just not one backend service. There are actually two services. Now, I've heard some people talk bad things about microservices. This is a real microservice that I have here that does profanity checks. Why is it a real microservice? I couldn't make it. This is the smallest possible service I could make, right? So you can't make it smaller, otherwise it wouldn't be a service anymore. But for example, if I was to say, well, could you tell me about, let's see, Wilson, and for those of you who don't know that, Wilson was the code name for a Microsoft library that does OpenID Connect, and it gives a lot of people a lot of grief. So if I submit this, it should say, oh, just please don't use the word Wilson, or something like, I don't know, Entra ID is also equally good, right? It will say, well, don't use the word Entra because of reasons. But anyway, there are two services here, right? There's the backend service that does this, and then this website also uses a profanity checker to make sure that we don't put foul words in here. Now, this React application has been built using just open source libraries. I will show you some. But most importantly, it does just like a lot of React apps do, by the way, or a lot of front-end apps, it does all the OpenID Connect interactions in the browser. And there are libraries to do that. Let me show you. I should probably zoom in a little bit. What I'm using for this is a library called, where is it? React OpenID Connect Context. Okay. Now the nice thing about this is that if I'm in a particular part of the application, so the app, for example, I can say something like, okay, we are using auth, and that already, and wrapping things then in this auth provider, make sure that all the endpoints like the callback and the token exchange and all of that stuff is taken care of, and I can simply ask it, well, is the currently logged in user authenticated? Does he have what kind of roles does that person have? So it's very convenient. It works. And what you see here is there there are off buttons here, for example, and it handles these things like sign in, sign out, and like I said, what's the name of the currently logged in user? Okay. Now, this is very common. I mean, a lot of people are doing this. Now, if I had a compromised package in the million of npm packages that I've used to build this system, then I would have already been vulnerable, right? Because somebody, that code gets built into my application, and now I'm vulnerable. But even if I don't have a vulnerable package, and I just do something that may look okay, but not quite, is, for example, to render a link, I'm using this, right? href equals website. This is something that, React handles something that is called, how do you say, the HTML sanitization for me. So if I do here, I can actually show that. If I was to put in here something that says this, let's do this, right? Now, this is something that a white box or a black box would always do, right? Find, see if there are problems here, and it's all nicely encoded, right? I mean, I can't click this, but it doesn't do anything. It doesn't, this link doesn't fire. I don't see an alert anywhere. So this is perfectly safe, right? There's no injection attack possible here. Well, maybe. Oh, did I log out? I think I logged out. Yes, okay. So let's see. What if I do this? And I'm just pasting a little bit of JavaScript here. Let me see. What's the JavaScript that I want? Okay, I'm not letting you see it. Let's say here, sorry, free beer. Free beer. Who would ever click a button that says free beer, right? What happened? Why am I getting a dialog box here now? What is yours is now mine. I don't know if you can read that. Okay, what happened here? Well, let's have a peek. I didn't want to build an application that actually sends this to an endpoint, but I hope that you trust me, the fact that if my JavaScript has access to this particular thing now, I could have, and this was JavaScript code that was triggering, so I could have gone here. So what is this thing? Well, that's an access token. And if I take a peek and I put it in a JOT decoder, you can see that, yes, I can see that it was Bob Smith. Let me zoom in a little bit. It was Bob Smith that logged in, who is he? And with this access token, I can start to do all kinds of nastiness. Now, this access token should be fairly short-lived, because we all know that, access tokens shouldn't be that long. So it's kind of like leaving that window open, right? It's okay, sure. Only if somebody clicks the link. So maybe, free beer, a lot of people will click this link. So a little bit maybe persistent token theft, but it's not that bad yet. Let's see if we can make it worse, because we always want to make it worse, right? I added, because I'm a good engineer, right? I added some HTML sanitization, because rich HTML text field will allow me to create HTML that I need to render on the screen. And if I don't sanitize my HTML, you'll see that dangerously set inner HTML. I'm doing something wrong. Now, to be fair, this sanitization logic may be a little bit naive, but for those of you who've not seen JS or anything, attackers can get very creative with how they can create valid JavaScript and inject it into pages. So even if you're currently using one of the, blessed libraries that does this, you might still be vulnerable. And let's see what you can do, for example, if you have that. Like I said, I'll close this window for a second. And let's do this. Hi, let me just delete these for just website. Nah. Sorry?
Oh, freebie gone.
Yeah, no more freebie. I'm sorry. Where do I have? Oh, now the thing is, whatever I do, because this control is built quite well, this one encodes my JavaScript. So, like I said, if I do this, it encodes it. So I can't put anything in here, right? Well, actually, we all know that you can just go to the console and put some JavaScript here. Which one should I do? I think it's this one. All right. So I'm bypassing the client-side changes now, and I'm posting something to the server. There's nothing wrong with that. I'm just posting something that is valid HTML. So if I enter this, review submitted successfully. Now I'll refresh. Okay, review. Okay, there's an image here, but it doesn't render quite well. That's fine, right? Somebody might just go to this page. I'll just completely refresh. Oh, doesn't matter. So the review is still there. I'll go to this page, just visit it, didn't do anything else. Let's have a peek. Hey, there's something else in the console now. This thing, and I know you can't see it very well. This is not an access token, so we're fine, right? No, we're not. This is a refresh token. Now, what possible things could somebody do with a refresh token? Well, let's see. I've got a little script here. Refresh token. What happens if I paste that thing in here? Hey, get a new access token. Let's try it again. Doesn't give me another one. Oh, this makes total sense because the access token was invalidated, but I get a new access token. Right? Now, this is something that people typically think that they don't have to worry about access or refresh tokens being stolen, because every time you use a refresh token, if you configure it correctly, you invalidate the previous refresh token. So right now, if I go back to the site, I'm no longer authenticated. My refresh token is no longer valid. My access token is, my refresh token is not. So you will eventually trigger a new sign in that will invalidate the attacker's refresh token, and we're safe, right? Because that's why they say refresh token invalidation protects you against these type of attacks. No, you're not. Because what if I hook up an event to the logout thing, and I just quickly, just before the user logs out, capture his refresh token, and then I use that to get new access tokens. The user's logged out, he's gone, he's walking away, and I've got his refresh token, I can just keep getting new access tokens. So there's a lot of people who always said, refresh tokens, the invalidation will protect you. No, it doesn't. All right. So I've given you now 2 examples of things that are happening in the wild, where even if you're trying to be a good developer, you're doing HTML sanitization, even in the browser, you're relying on React, for example, to protect you with that. Even despite these things, you can still lose your access tokens. And honestly, the way to solve this is not by being more diligent, better reviews of the code that you're writing. No, the solution is to eliminate this kind of problem altogether. Now, how would you do that? No more access tokens in the browser. All right, let's have a peek to the rest of the presentation. Because there is a BFF pattern to the rescue. Now, BFF was already coined for a backend for a front end, right? If you're building a mobile application and a website, you could say, well, you have an API service that is available to both of them, but that means that if you want to evolve these API services, that is harder. So there are a lot of companies who are saying, no, you should have one API surface for one front end. And that is effectively what the BFF pattern is. Unfortunately, the guys who came up with the security pattern for this, and that's why I typically call it the BFF security pattern, they said, well, yes, this is also a backend for a front end, but then a backend for a front end that also helps you with authentication. So it is still a backend for front end, but slightly different. So that's why I always say backend for front end security pattern. Now this is what that looks like. Now it looks a little bit complicated, but I'll just walk through it in steps. First of all, when I said the React-based application it did all the OpenID Connect flows in the browser. Well, we shouldn't be doing that, because then the token is posted to the browser intercepts that and handles it. No, we don't want that. The browser should never handle those access tokens. So what you do is you let the server do that. You simply redirect from the browser to a login endpoint, /bff/login, for example. That triggers a redirect to the identity provider, and your authentication flow happens. And when you are done with the authentication, your identity provider has said you're logged in, you're redirected back to the backend, and it does the authentication for you and stores a cookie. Now you might say, well, yeah, but information is still going via the browser. That's correct, but the access token does not. The access token goes, if you configure it correctly nowadays with recommended practices, goes here. You only share here an authentication code, and that can't be used. And even if it could be stolen and abused, the browser-based application doesn't have access to this, because that interaction here happens on a different site. Remember, sites were separated, but within a site you couldn't? Well, that's the other reason. Now cookies, we're relying on cookies. I set the endpoint for login state, yes. Cookies have gotten a little bit of a bad name in the past. And because of that reason, actually a lot of security features have been added to cookies. Because if you remember back in the old days, we were on the MySpace or whatever, and somebody stole your cookie and then they could do stuff with that cookie. Well, yes, but that was before, for example, cookies traveled over HTTP, not HTTPS. Well, now you can just say a cookie is only HTTPS only. It will never go over HTTP, so they can't intercept it. That's already better. Another security measure is that you can mark a cookie as HTTP only. Now that is a terribly chosen name, because I just said HTTPS only, and now HTTP only. What's the point is that if you set it to HTTP only, it means that your JavaScript will never be able to access the cookie, but it doesn't say that it's going over an unsecured connection. So an HTTP only cookie is not accessible by your application. If you're doing JavaScript, doc cookies, and you look for it, it's not there. So that means is that even if you get an injection in here, they can never steal your cookie, and therefore can't steal the access token that may even still be in that cookie. It's in the browser, but it's not available to your browser-based application. It's very important. Now, if you do this, if you use cookies to secure your site, you have to implement something that is called CSRF protection, cross-site request forgery. Now, I don't think I have time to go into what exactly that is, but it's really easy. .NET already has CSRF protection built in. Actually, it does it quite complex, because if you have a SPA-based application, is what we're talking about here, it is much simpler to do this by simply adding an HTTP header. Now, I won't go into the details on why that is, but believe me, setting that HTTP header kills CSRF attacks in its tracks. All right. Then we have another challenge, because remember when I said that the example application actually had two services that it worked with, right? It had the backend, which stored the reviews, and that profanity checker that checks if you're using any silly words. Now, the problem with cookies is that they are only sent to the same origin, to the same site. And that means that if you have that thing on another site, your cookie won't travel there. And even if it would, it's not a good idea to have two different web servers being able to read information from the same cookie. There's just a boundary that you're crossing there. So that's not a good idea. So what should we do then? Well, the BFF can proxy requests to other services, and in that proxying, it will do a token exchange. It will take the cookie, read information from it, exchange that for an access token, and then forward the access token on. And that is perfectly fine, because that access token never travels over via the browser, right? This is server-to-server communication, so using access tokens there is perfectly fine, right? Now, lastly, when you have a BFF pattern implemented, server-side session management can help. I say can because it also has downsides. The big downside is that if all your authentication state, like your access token and that kind of stuff, is in your cookie, every request has enough information to know who that user is and what that user can do. If you store that information in a database, then now every request needs to go to the database and find out, who is this particular user that's associated with that cookie. But the advantage is, well, first of all, your cookie gets a lot smaller. But second of all, as soon as you delete that record from the database, the user's logged out. And you can't do that with an access token that's already given out unless you have a revocation list or something. And you can't do that with a valid auth cookie because the cookie lives in the browser, it doesn't live on the server. So if you want to have server-side sign-out, even remote server-side sign-out, you need to have something like session storage, server-side session storage. Okay? Now, for hosting a BFF, there are a lot of options, but this is always my preferred one. I always like to store all the what I call static assets, so the HTML, the JavaScript, the images, all of that stuff, I put that on a CDN, because those things are just made for serving static content. And the browser can directly just go to those things and retrieve that static content. And because no authentication cookie needs to travel for that, this is perfectly safe. The whole web is built on getting static content and script assets from all over the place. However, the entry point for my application, the index HTML, if you want to call it like that, is served by the BFF. And I typically proxy that then. That's what this line means. So that when you just go to yourapp.com, that's where that's where the user thinks that he's interacting with. And all the rest of the static content can be retrieved directly from the CDN. And you can, if you're using like Feet or NPM or something to build your sites, there's just one flag that you say, this is my CDN URL, and it just embeds that all. It's all taken care of, so you don't have to worry about that. But this is the best pattern to run a BFF, so to speak. All right. So I still have time. Great. Let's just see what that would look like if we were to change the existing code to use a BFF, just from a reputable supplier. Let's see. I may have been involved with building that thing, so that's why I keep saying these things. But honestly, if you know what you're doing, you can also build one yourself. It's not that particularly hard. I know. If you want to get all the fancy features, then it is good to use it, but otherwise, I know. All right, so I'm going to apply a stash because I can't code very well in front of an audience, but I'll show you a little bit of the differences. So let's look at the server first. Now, on the left-hand side, you see that originally the server was saying, oh, we're going to validate just bearer tokens coming in, right? Because the browser had an access token and it sent it across as a bearer token. That was all that we needed. Now, no. We need to say, server, on the right-hand side, you need to use OpenID Connect as a flow there. So you do that, you say add authentication, you add cookie handling, and you say add OpenID Connect with all the parameters, and that's it. Now,
Add some usings.
Well, add some using. Yeah, okay, sure. Now, in this particular case, I'm also saying add BFF because that thing ties a couple of things together, and it also gives you that remote API proxying, the token exchange, server-side sessions, and all of that goodness. This is still, by the way, BFF v3. BFF v4 has a more densely API and also does multi-frontend and all of that stuff, but this is the most straightforward example that I could give. Then this is a very important one, map management endpoints. So what that does is it will expose a couple of fairly straightforward endpoints, log in, very important, log out, and get current user information. Because again, the browser can't access the cookie anymore, or the token, so it doesn't know who the currently logged in user is, so you have to query for that information. That's what this thing does. Then in the React-based application, unfortunately we do need to create something that mimics that behavior that we saw earlier that says, well, give me some authentication state. Now, This is just React. I mean, you don't have to do it this way. If you were to start from scratch, you can also bypass this and code something that's simpler. But I wanted to give you exactly the same behavior inside of your React app that you got on the other side. So what this authentication provider does is it says, well, when you start up, that's what useEffect does, you query the BFF user endpoint, add that header. Remember that I said that header is CSRF protection. That's all that you need for CSRF. Well, this is an example. You add that header, include credentials to make sure that the cookie flows, and then you get back a list of claims if you're authenticated. If you're not authenticated, you get access denied, and that's fine. And all that you need to do then is store that in the same way that the React component would do, so to speak. So that's fairly straightforward. And then there's one additional change that you need. I mean, I could have done it slightly differently, but I think there is... Oh, well, of course. One thing that you also need to change is that before, on every request, I needed to add something that says, well, fetch with auth. See, I needed to add the bearer token to all of my HTTP requests. So I had an interceptor there that says, well, when you do an HTTP call, attach the bearer token. I no longer need to do that because the cookie automatically flows if it's there. What I do need to do is, again, add that CSRF header. If you don't do that, you get access denied all the times, get a bad experience. So, and then the rest is literally just, well, okay, here's an example. I added the CSRF header here explicitly. Didn't need to do that. What else? Yeah, the auth buttons, where before the library was saying auth.signout redirect. Now, or sign in, well, logging in is really straightforward. You just say navigate to this URL and we're done. That's it. If you want to sign out, if you build your own library, then of course navigating to /logout would work. However, navigating to a URL, doing a get, is what the browsers consider a safe operation. So if somebody wanted to annoy you, they could have a different application, like an iframe or some other window in another thing that constantly is polling your logout URL, and then it constantly logs you out. Of course, you need to have two windows open, but there is like a denial of service attack possible if you're visiting one site that's just annoying you on the other side, so to speak. So that's why we've added some kind of session ID, that the only way how you can get access to that session ID is if you are logged in, if you've gotten the access information correctly. So there's a little bit of a jiggle that you need to do here to prevent those types of attacks. Doesn't matter, the BFF takes care of that. But then if I've done all of this, the experience is now subtly different. Let me restart this application. I probably should have stopped it before I switched the code underneath, but I'm sure it will work. All right. Now, remember what I said is that before we were going to the web server directly. Now, by the way, it is still possible if you really want to take your CDN or whatever you use as the entry point, you can still do that, but then they need to be on the same site, otherwise the cookie doesn't flow and it's just way more complex. So like I said, what I typically like to do is that you just navigate to your backend. It's really, that's where you go to, and that thing proxies the index.html, and all your React static content will just be served as you would expect. Now, I'm not logged in. There's no authentication cookie. If I click the login button, I was already authenticated in the identity provider because my cookie was there, so you do have that single sign-on. I didn't implement silent login flow here. It's really straightforward, but I just didn't implement it in the React app. So otherwise, you would have just gone to the URL, it would have checked and logged me in automatically. But now I'm logged in, but there's no more access tokens. So none of these attacks that I showed you earlier would have worked. I mean, I can try, but the access token is just no longer in the browser. So now, with fairly few changes, I have completely eliminated a set of threats to my browser-based applications. And yeah, you can do this. I mean, you can do this in C# by using either YARP or BFF library. Other kinds of languages have similar technology, so there's just no more reason to do this in my perspective. Well, I'm already done.
Perfectly on time.
Beer or questions? Well, I've got more slides if anybody wants more slides, but it's that's pretty much it.
We have a question here.
Oh, we have a question. Sorry. Yes, please.
Question. So you have a front end, which is a React application.
Yes.
And you have basically your BFF that your front end communicates with.
Yes.
On your local machine, that's all fine. It's all localhost. But in reality, I have a front end application that is hosted on a different host name than my backend application.
Yes.
And then you're in trouble when you want all the cookie settings to be as safe as possible because they cannot travel over a different host name.
Yes.
So if I want to implement this BFF, I have to either host my BFF under the same host name as my frontend or do something there to make it safe.
So you're absolutely right. What you're describing is what we call a split host scenario, and then your front end and your back end needs to be under the same site. And the site is defined as top level domain -1. So if you have .co.uk, that is still your top level domain, even though it's 2 parts. And then whatever is before that, Google, your company, whatever, that's your site. And anything that's under there could share, if you wanted to, the same cookie. So if you have api.mycompany.com and web.mycompany.com, they could share the same cookie. I don't necessarily recommend that because it is more difficult and, like you say. The other pattern, which I do recommend, is you still have those 2 web servers, right? It's the CDN web server or wherever you get your static content from, and you've got your front end. Now, instead of redirecting your users going directly to your, instead of your users going directly here to the CDN or whatever URL that is, you say, no, your users go here. Now, of course, right? If your users are already going to the application URL and that was just pointing to this thing, you make a change in your DNS to say, no, that's not going here anymore, that's going here, right? So the user doesn't see any difference. The user simply just goes to the application.url. Then this thing, the app, goes to your server, and the server then fetches only the index.html, nothing else, only the index.html from here, serves that to the browser. And if you have in your index.html all the URLs configured so that they always get the static assets directly from the CDN, this just works perfectly. If you didn't do that, then you can tweak some things with a base that you put into your index.html to still get that same behavior, but you have to jiggle URLs a little bit more.
Yeah, sure.
But
I host everything on Azure Static website. So what you just did to put the BFF in between basically means for me a little bit more work to get it done.
you have an infrastructure component there. You're absolutely correct. That is, you need a backend component. There's no longer, absolutely. There is a backend component here. Sorry.
With the multi-host scenario, maybe I'm mistaken, but can't you fix that with proper core settings to allow the cookie to
Oh, you can get it absolutely.
different domain?
You can add. No, you can't do it to a different. You can't say this cookie needs to flow both to google.com and some other site.com. Those are, yeah, no. That won't work. You can only do it within the same site because otherwise, tracking you across sites would have been tremendously easy, right? I mean, how does the server the cookies are being sent implicitly. You don't have any control over that. So otherwise, every cookie would be sent to every site. That would have been a little bit too much. But I still don't really recommend the split host scenario if you can avoid it. Now, yeah, what he said is absolutely true. You do need some kind of infrastructure component for this. It would be really nice if you would be able to plug something in, for example, your Azure infrastructure. That would be interesting. We're thinking of that anyway. So yeah, other questions? No? Well, I hope it was clear. Thank you very much for your attention and for staying awake for the last session.
Thank you, Erwin.